let's prove the alternate interior angles theorem. Prove that if two parallel lines, there's P and Q, are cut by a transversal, that's T, then the pair of alternate interior angles, that's 1 and 2, are congruent. So we're given that P is parallel to Q, that's the symbol for parallel. There's the symbols. Prove that angle 1 is congruent to angle 2. All right. Generally, when we start off a two-column proof, we start with a given, and that is P is parallel to Q, and we get to write the reason is that it's given. Now, I see that I have a 3 here that I haven't mentioned yet, but I do know that we have studied corresponding angles, and 1 and 3 are corresponding. And we had a rule that said that if the lines are parallel, then corresponding angles are congruent. So I will state that the measure of angle 1 is congruent to the measure of angle 3, and that will be the corresponding angles theorem. We'll abbreviate theorem THM. All right. Now that we've said that 1 and 3 is congruent, we can talk about how 3 and 2 are congruent. Now 3 and 2 are congruent, and if you look at their placement, they're opposite of each other. They're created by two lines in their opposite directions. That would be vertical angles. So vertical angles are congruent. You can use some symbols here. Vertical angles are congruent. You can use those symbols instead of writing the words, as long as you know what they mean. And now I can state that 1 and 2 are congruent. The reason I can is because here I've said angle 1 is congruent to angle 3 and angle 3 is congruent to angle 2. Do you remember earlier in a video where we had that theorem that stated that if A is equal to B and B is equal to C, then A equals equal to C? I can state exactly what I want. Angle 1 is congruent to angle 2, and that was the transitive property of congruence. We'll abbreviate property of congruence. And we're done. Short little proof.